Hi, it's Mr. Anderson, and today I'm going to talk about energy, work, and power. Now, what is something that has energy? It's a pretty big term. So what things have energy? Well, we would say something in motion or something due to its position. We could say that electricity is a form of energy. We could say that matter can contain energy within its chemical bonds, or light has energy, or sound has energy. So that's a lot of different things. What is energy? Energy, therefore, is the ability to do work. Well, that's one of those definitions that requires us to dig a little bit deeper. What is work? Work in science is simply a force times a distance. So anything that can apply a force over a given distance is said to contain energy. And we measure that in joules. So work is measured in joules. And so let's give an example. Let's say, for example, that you want to take a can of Coke and you want to carry it to the top of a set of stairs. Well, that can of Coke has 4.0 newtons of weight, and let's say that you have to climb up a set of stairs that is 3.0 meters high. Now, the interesting thing is that since the gravitational force is always acting down, it doesn't matter if you get to the top of the stairs by walking upstairs, or get to a similar distance by climbing up a ladder, or simply just throwing the can of Coke up to that point. If you've moved it up a certain amount of distance, we'll call that 3.0 meters, then you've done 4.0 newtons times 3.0 meters, or 12 joules of work to get that to the top. Now, you could get that to the top in a couple of different ways. Let's say that we were to gradually make our way to the top of the stairs, or we were to run up the stairs. Well, we would be doing the same amount of work depending on if we're running or going slowly. And so we need another term to figure out how fast we're doing that, and that's called power. And so power is defined as the amount of work in a given period of time. And let's say that you were to go up that set of stairs with that can of Coke, and you were to do that in 1 second. Well, the amount of work we have is going to be 12 joules, and the amount of time is going to be 1 second. And so the power of that is going to be 12 watts, or W-A-T-T-S, or watts is going to be the amount of power that we have. If you were to do that slower, so let's say we were to do that in 10 seconds, then the amount of watts would drop from 12 watts to 1.2 watts. So that's really not that much power. And so the amount of power that we're actually used to dealing with here in the US is horsepower. And so horsepower is measured it measures the amount of work that we can do in a given period of time. We use it in engines, for example. And so the conversion is 1 horsepower is roughly 746 watts. And so let's go back to that problem. If we're able to move a can of Coke to the top of the stairs in 1 second, we say that that's 12 watts. So if we convert that to horsepower, then we are a 0.004 horsepower machine. So that's not a very powerful machine. Now, the one thing that you should realize is not only are we moving that can of Coke to the top of the stairs, but we're also moving our weight, our whole body, to the top of the stairs. And so maybe we're a little more powerful than we think.